Hello, Algebra 1. Today we're going to revisit the topic of factoring trinomials, except this time our trinomials will have a GCF that is not equal to 1. Let's go right into our first example. Here we have 6a to the 5th plus 14a cubed, and the way we're going to do this factoring is by calculating the GCF. So I'm going to create this rectangular box, and in the first box I'm going to put 6a to the 5th. On the second box I'm going to put 14a to the 3rd power. And then I'm going to figure out what is my greatest common factor. Right? What's the greatest number that divides into both 6 and 14? That would be 2. What's the greatest power of a that divides into a to the 5th and a cubed? You'd always take the smaller power, which is a cubed. And then from there, we would carefully multiply this out, right? 2a cubed times 3a squared gives me 6a to the 5th. 2a cubed times 7 gives me 14a cubed. Here, there's no operation between 3a squared and 7, so the default is a plus. When you write down your final answer, it will be 2a cubed times the quantity of 3a squared plus 7. And this is my final answer. Right? This is what you get when you factor. Remember, when you factor a polynomial, what you're doing is you're writing it as a product of things. So just keep that in mind. Now, at this point, I'm going to show you another way you can actually find the GCF. You might like this a little bit more. So I'm going to first just copy down the two terms again. And what I'm going to do is I'm going to write each term as a product of its prime factors. If you remember creating like a factor tree, right, to find the prime factors, we're going to do something kind of similar. So 6a to the 5th, right, 6 is 2 times 3. A to the 5th power is just a times a times a times a times a, right, 5 of those. Plus, and then 14 is 2 times 7. A cubed is just a times a times a. And then from there, what I'm going to do is I'm going to look at what they have in common. They both have a 2. So I know my GCF is going to consist of at least a 2. Now, if you notice here, they both have an a. So let me include another a. I see another a that they both have in common. So let me include that. Looks like they have one more a in common. So let me include that as well. Now, at this point, you multiply this out, and you're left with 2a cubed. And if you notice, that's the GCF we got earlier. And that's your answer, right? That's how you can find the GCF. So at this point, when the video says your turn, I want you to pause the video, try number 2, and when you're ready, press play. Now for number 2, the GCF here would be 4x squared. And then from there, what I'm going to do is I'm going to just write it like this. Again, you could think of it as reverse distributive property. 4x squared times what would give me 8x to the 6th. That would be 2x to the 4th. 4x squared times what would give me negative 20x squared. That would just be minus 5. And this would be my final answer. Hopefully you're able to find the GCF correctly and then factor it out. If you made any mistakes, just learn from it moving forward, okay? Let's move on to number 3. Now for number 3 here, I don't want you to copy down what I'm going to write right now, okay? So if I was to factor this out, I would normally create a box, right? I would put 10x squared here, I would put 100 here, and then I would create my x. The product would be the product of 10 and 100. If I multiply 10 times 100, that would give me 1,000. And then my sum would be the coefficient of my middle term, which is just 70. And then I'd ask myself what two numbers multiply to 1,000 and add up to 70. Now what happens is these numbers are so big that they can get very difficult. And the reason why this problem is so difficult is because if you look back at the original question here, and you look at the three terms, 10x squared plus 7x plus 100, there is a GCF. And because I didn't factor out the GCF, what ends up happening is I end up with these numbers that are so huge, and they make it very difficult to solve. So what I'm going to do is erase this, and we're going to start all over again. But this time what we're going to do is we're going to factor out the GCF from the very beginning. And we'll see how this makes the problem so much easier to factor in the end. So we said the GCF was 10, right? If you carefully factor out the GCF, you should end up with x squared plus 7x plus 10. Now from there, I know that when I factor this further, I'm going to have 10 times, and I need to fill out what those other factors are. So at this point, what we're going to be focusing on is factoring x squared plus 7x plus 10. So let me put that right here, and we're going to focus on factoring that. So how we're going to factor that is by creating a box, right? I'm going to put x squared on the top left, plus 10 on the bottom right, and then I'm going to create the x. It's going to multiply to 10, because again there's a 1 right here, and you're just multiplying 1 times 10, which is 10. The sum is going to be 7, because that's the number in the middle, right? The middle coefficient. And then I'm going to ask myself what two numbers multiply to 10 and add up to 7. If you guess 5 and 2, you're correct. From there, I will put 5x in one box, 2x in the other box. And this first box has an area of x squared, so I know it's going to be x times x. And then from there, you can carefully kind of fill out the rest, right? That would be plus 2. This one would be plus 5. And then if you want to do a little check here, if I multiply 5 and 2, I do get 10, and that works out nicely. And so now when I write down my final answer, I'm going to write 10 times the quantity of x plus 5 times x plus 2. And this would be my final answer. So that's why factoring out the GCF is so important. You always want to do that for your first step. So let me actually write that down right here as a reminder, right? Always factor out the GCF first when factoring, okay? Anytime, and I mean that, anytime you are factoring, always look for the GCF. Let me use purple for this one. So keep that in mind, okay? Let's look at another example here. Let's look at number 4. So here we're going to look for the GCF, which in this case is just 2. And then from there, we're going to carefully factor out my 2. I'll be left with 3x squared minus 2x minus 8. And if you're not sure if you did it correctly or not, what you can always do to double check your work is by taking this 2 and just distributing it back, right? And the goal is you should end up with the original problem. And if you don't, then you know you made a mistake. So now from here, what we're going to do is we're going to be focusing on factoring out 3x squared minus 2x minus 8. I know that in the end, my final answer is going to have a 2. And now I need to figure out what goes inside those parentheses. So let me put 3x squared minus 2x minus 8 here, because this is going to be our main focus. As usual, we're going to create a box. In our box, I'm going to put 3x squared on the top left, put negative 8 on the bottom right, and then I want to create my x. To figure out what my product is, what we're going to do here is we're going to multiply the first number and the last, right? We get 3 times negative 8, which is negative 24. To find the sum, that's always going to be my middle coefficient, or the coefficient of my middle term, which is negative 2. And then I'm going to ask myself what two numbers multiply to negative 24 and add up to negative 2. That would be negative 6 and positive 4. And then from there, I will put negative 6x here. I will put 4x here. And then we need to figure out what goes on top and on the left. So the way I'm going to do that is what I'm going to do is pick a row or column and find the GCF of that row or column. I'm going to pick the first column here, 3x squared and negative 6x. When I find the GCF of those two terms, I should get 3x. Verify that that is my GCF. And then we can fill out the rest, right? 3x times x gives me 3x squared. 3x times negative 2 gives me negative 6x. Here I'm going to put a plus 4. And then we can do a little check here. Negative 2 times positive 4 is negative 8, which is great. And so when I write down my final answer, I'm going to put 3x plus 4 here, and then x minus 2. And this would be my final answer. So hopefully you're kind of seeing this pattern, right? It's very similar to what we did earlier this week. The only difference now is that you're factoring out the GCF first, right? So at this point, what I want you to do is when you feel ready, pause the video and try number 5 on your own. Let's see how you do. So here, what I would do first is look for the GCF, which in this case is 3. Carefully fill out the rest, right? You should have got 4x squared minus 4x minus 3. So I know that in the end, my final answer will have 3 times, right, something times something. And what we're going to do here is we're going to be focusing on factoring 4x squared minus 4x minus 3. So I'm going to just put that right here for now. I'm going to create a box. Inside this box, I'm going to put 4x squared on the top left, negative 3 on the bottom right. And then to figure out what goes in the diagonal boxes, I need to figure out this x problem. I know the top is my product, which is going to be the first number times the last number. So 4 times negative 3 is negative 12. My sum will be negative 4 because that's the coefficient of my middle term. And then I'm going to ask myself what two numbers multiply to negative 12 and add up to negative 4. If you guessed 2 and negative 6, you are correct. I'm going to put 2x here. I'm going to put negative 6x here. Now at this point, what I'm going to do is pick any row or column and then find the GCF. And it doesn't matter which row or column you pick because in the end, you'll get the right answer if you did it correctly. So for this one, I'm going to choose the first row. And then I'm going to ask myself, what is the greatest common factor of 4x squared and negative 6x? It should be 2x. 2x times 2x gives me 4x squared. 2x times negative 3 gives me negative 6x. This should be a plus 1. And if you want to do a quick little check here, 1 times negative 3 is negative 3, and I know that's correct. If for some reason this never works out, like if one of the boxes is wrong, that probably means you made a mistake and you have to go back and check your work, okay? But at this point, this whole box fills out nicely. So I know my final answer will be 3 times the quantity of 2x plus 1 times 2x minus 3. And this is my final answer. How'd you do? Hopefully you were able to get this correct. If you made any mistakes, really pay attention to what mistakes you made and learn from it moving forward, okay? Let's do number 6. This is the last question for today. Try number 6 on your own. Let's see how you do. So for number 6 here, my GCF is 2. If I factor out my 2, I'll be left with 5x squared minus 3x minus 3. And then from there, what we're going to be focusing on is factoring out this 5x squared minus 3x minus 3. So let me put 5x squared minus 3x minus 3. I know that when I factored, I'm expecting 2 times the product of 2 binomials. Now here we're going to create an x box. 5x squared goes here, negative 3 goes here. Then I'm going to create my x. For my product, it's going to be 5 times negative 3, which is negative 15. My sum will be negative 3. And then we want to ask ourselves what two numbers multiply to negative 15 and add up to negative 3. Now if you notice, there are no numbers that would work here. Nothing works. And so when that happens, what that means is you can't factor this trinomial any further. So this is actually my final answer. Sometimes that's going to happen, right? You're going to get a trinomial that you just can't factor. It's not possible. And so what we do then is we call this trinomial a name. We can say it's prime. Another word that you can use to describe it, and they mean the same thing, is that it's irreducible. And that just means you can't factor it any further, right? You're done. And so sometimes you will come across polynomials where you cannot factor, right? Aside from the GCF. But just be very careful though when you think something's not factorable. Like double check your work, because if it is factorable and you think it's not, then you're going to get it wrong, right? So guys, this is today's lesson. Just always remember, anytime you have a factoring problem, always factor out the GCF first. I hope you guys are feeling okay with this concept in general. Have a wonderful rest of your day, guys.